succeed for the formula today, it won't be as complex of a formula tomorrow. This is just your continuous compound interest formula with slightly different variables, right? You guys remember A equals PE to the RT? P stood for principal in a bank account. A sub 0 is just standing for the initial amount. This little 0 is not a number or a variable. It's indicating that this is the amount at time 0. So you're not plugging in 0 anywhere. So it could be the initial amount of bacteria in the Petri dish. It could be the initial amount of radioactive substance that has to now decay over time. It could be the amount of carbon in the tree at time 0, and now how much carbon is left after like 1,000,000 years. So it's the initial amount, just like P was your initial value of money. E is representing continuous growth or continuous breakdown of your radioactive material. R was our interest rate when we were dealing with money. K is just a constant. How fast is the water cooling? How fast is the bacteria growing? So K is going to change in every situation based on the environment. Can the bacteria grow really fast in their Petri dish? Or is the water cooling really fast in the refrigerator? Right? So K changes based on the environment, and T is still time. So this is the exact same equation that you've been using. It's just made for all of our situations now. So it says in our last adventure, we applied formulas for interest using A equals PE to the RT. This is just the general form for any exponential function. So in the formula, A sub 0 is the original amount, K is a constant, T is time. Here's something that's important. If K is positive, right, it must be an increasing function. Bacteria growth, interest growing in a bank account. But if K is negative, right, the function is decreasing. So it could be population decay over time, or radioactive decay, or temperature cooling. So your K is going to be either positive or negative. Make sure if you're solving for K, your K makes sense. Like, oh, my K was 9.5, but my temperature should be decreasing, right? You probably did something wrong. So your K value needs to make sense. Classic examples for increasing: compound interest, population growth, decay, radioactive decay, for carbon dating or carbon depreciation. So it says the simplest application is when you know your initial amount, your constant, and the amount of time. So if you're studying some organism, you'll know K. You could just apply the K to that situation. So this just says the size of a certain insect population in days, T is days, can be modeled by this equation. So what's the population after 1 week? So I can just use my equation and plug in 7 and get the output. So I'm using the application, or sorry, I'm using the equation to solve an application problem, but I know what K is. So I'm just going to do 500 times E. Think of 0.02 as your interest rate, right? And then after 7 days, what's the insect population? And K is positive, so your population of insects is going up. So you have about 575 insects at the end of a week, right? So type it all in one fell swoop, 500e to the 0.02 times 7. All right, and then this next one, sometimes we know the current population, so A is our current amount. We know K and T, but we want to go back in time and figure out what A sub 0 was. So it may look intimidating, but E to the KT is just a number, right, if you know K. So just like with compound interest, we did this, like, how much do I have to invest now to have $100,000 at the end of 3 years? So this says the size of an insect population has reached 10,000. So that is A. We don't know A sub 0. That's what we're looking to solve for. We know E. K is 0.05, and it took 3 days. So we want to figure out what the initial population was so that when I multiply by e to the 0.05 times 3, I get to 10,000. Whatever you get here, you're going to divide to the other side. So type e on your calculator to the 0.05 times 3. So that would be 1.16. Divide by 1.16 and you'll get your answer. So 10,000. I like to keep it on my calculator so that I can just divide by the entire decimal. I don't know how different it would be if you just did 1.16. You'll be off by like 13. So if you keep the whole decimal place, 8607 is the correct answer. If you round it to the 1.16, 8620. So you're going to be off a little bit. So try to keep all the decimal places. So 8607 would have been the correct answer. And I think, is example 3 when you have to solve for k? So we'll save solving for k for next time. This is just an introduction to that equation. And that's not